Let's write the IUPAC names for the following alkenes. If we number left to right for molecule 1, then we would be giving higher number for the alkene and lower number for the methyl substituent. However, we should give lower number for the alkene. Therefore, we have to number right to left in this case. So if we number right to left, then this is 1, 2, 3, 4, 5. Now the alkene comes at 2 position, this one, and the methyl group comes at 4 position. That is correct. Therefore, the correct IUPAC name for this molecule is 4-methyl pent, because we have 5 carbon atoms in the parent chain, 2-ene. That's the correct IUPAC name for this molecule. For molecule 2, the parent chain is this one. We have to number starting from here, this methyl group, so that the alkene comes at 3 position. Therefore, number it 1, 2, 3, 4, 5, 6, 7. Our long continuous carbon chain contains 7 carbon atoms, and there is a methyl group at position 3, and therefore the correct IUPAC name for this molecule is 3-methyl hept 3-ene. If we number it on the other way around, what will happen? The alkene will come at 4 position. That is incorrect. Let's write down the name for structure 3. If we do the numbering left to right, 1, 2, 3, 4, then the alkene comes at 4 position. On the contrary, if we do the numbering right to left, then the alkene comes at 3 position, and therefore that is preferred. We have to give low number for the alkene. We have 7 carbon atoms in the parent chain. Also, here geometrical isomerism is there, and therefore we have to specify that. So we have a hydrogen atom here. We also have a hydrogen atom here. As per Kahn-Ingold-Prelog rules, carbon gets higher priority here because the atomic number of carbon is 6 and the atomic number of hydrogen is 1, and therefore that would get least priority. So here also 2, and then this carbon will get the top priority. Our priorities are on the opposite side here. That means this is a E isomer. If the priorities are on the opposite side, that is a E isomer. Therefore, it is 3E hept 3-ene. That's the correct IUPAC name for this molecule, specifying the geometrical isomerism. Imagine this way. Let us say the structure is given like this instead. 1, 2, 3, 4. Let's say if the structure is given like this, how would you name it? 1, 2, 3, 4, 5, 6, 7. Now the higher priorities are on the same side, isn't it? We have hydrogen here, we have hydrogen here. So as per the Kahn-Ingold-Prelog rules, if we assign the priorities, then the priorities are on the same side. This will be 3Z hept 3-ene. Therefore, mentioning geometrical isomerism is important whenever the structure is mentioned in a specific way. Let's work on structure 4. Here we have to do the numbering left to right so that the alkene gets lowest possible locant. Because if we do the numbering on the other way around, the alkene will come at position 5. That we shouldn't do it. We have 2 methyl groups, one at 3, one at 6. Also, we need to specify the geometrical isomerism for this case. Therefore, let us assign priorities as per Kahn-Ingold-Prelog rules. We have a hydrogen atom here that gets low priority, carbon atom here, higher priority, carbon atom here, and here also carbon atom. So now this carbon has 2 hydrogens and 1 other carbon atom, whereas this carbon has 3 hydrogen atoms, and therefore this gets higher priority, this gets low priority. Here once again the priorities are on the opposite side. Therefore this is also E isomer, and we have 8 carbon atoms in the parent chain. Therefore the correct IUPAC name for this molecule is 3E in parenthesis and then 3,6 dimethyl oct 3-ene. That's the correct IUPAC name for this molecule.